Yeah, welcome to SEPAM. Today we are going to look at understanding refraction with Orisheje Matthew. Level 1, understanding refraction, level 1. What is refraction? Refraction is the change in the direction of light or wave as it travels from one medium to another with different optical density. So if you have this like glass with a refractive index of 1.5 and then you have air, so if light is traveling from air, then an imaginary ray line perpendicular to the interface is known as a normal, and if you draw a normal at position A ray of light coming from air which is moving faster, so you see this ray of light is traveling faster. As soon as you enter the glass, it slows down. The reason is that the density, optical density of glass is more than that of air. So as soon as the air enters into the glass, the speed slows down. That is what is responsible for the bending of the light or the change in light direction. That's supposed to be the original part. How does the ray of light bend? Why does the ray of light bend? And how does the ray of light bend? So you have a ray of light traveling from air to glass. The incident ray, just to show purple, is the same ray of light, but just for contrast, as I'm using different color here. The one in air, the ray of light in air with this purple color, when it enters into the glass, just to show why it's traveling through the thicker medium. So for contrast, I'm using this red ray. Now you see the difference in the speed. The refracted ray bends towards the normal if the light is traveling from less dense medium to a more dense medium. Like in this example, it's traveling from air to glass. So the ray is bending towards the normal. The reason is because the speed reduces. The light slows down on entering the glass. So, and then the ray that travels through the glass that is bent is called the refracted ray. While the ray that is incident on the glass that is traveling through the air is called the incident ray. The speed of light in glass reduces. Like the speed of light here is about 300 million meters per second, but the speed of light in glass is going to reduce to 200 million meters per second. How does the ray of light bend? When the light is traveling from more dense medium to a less dense medium, the refracted ray bends away from the normal if the light is traveling from more dense medium to less dense medium. In this case, it's traveling from glass to air. So you discover that the ray bends away from the normal.
Do you want to get an A+ in Cambridge IGCSE Physics?
Of refraction
Make the smart
increases,
choice of subscribing to Super
while
Easy
the angle
Physics
of
and
incidence
Mathematics.
in the glass
For
is
sure, you
smaller
will
than the
benefit
angle
from
of
Mr.
refraction
Matthew wealth
in
of
the air.
experience of preparing students to get an A+
The reason
in
is
Physics.
because the light speed up on entering air from glass. The speed increases from 200 million meter per second to 300 million meter per second. So the refracted ray, that is the original part. So the speed of light increases. That is why it bends away from the normal. See how to label a ray diagram to show refraction. At the point of incident, you have the normal. The ray that is incident at that interface is called the incident ray. The angle between the normal and the incident ray is called the angle of incident I. Then the refracted ray is bent towards the normal because the glass is thicker than air. And the angle between the refracted ray and the normal is the angle of refraction, R, as labeled in this diagram. What happened to the wavelength as light travels from air to glass? So you have a laser beam that is traveling from air, and then at the interface of air glass, you see that the laser beam, the refracted wave, bent towards the normal. If you look at the wavelength here, the wavelength in air is longer, while the wavelength in glass, lambda g, the wavelength in air, that is lambda a, to show you the wavelength in air is longer, while the wavelength in glass is shorter. So the point is, wavelength reduces as light travels from air to glass. Point number 2, the frequency of the wave remains the same as light travels from air to glass. The velocity reduces, the wavelength reduces as light travels from air to glass, but the frequency remains constant. So it's the point to note. Thanks for learning. This is the end of level 1. Lesson with respect to understanding refraction.
Mathematics. For sure you will benefit from Mr. Matthew's wealth of experience of preparing students to get an A+ in physics.